Okay, you all. Day 3 video. Here we are. And while I think I have the mic working this time, my pen stopped working, so I had to stop and take a break, and now I'm back. So, we're verifying identities in this section, and this is going to look very similar to what we were already doing. But a lot of times people will find this easier because instead of just an expression that you simplify, you're showing that one side equals the other. So when you know the direction you're going in, sometimes that helps. So they have some guidelines for us that are on page 380 in your book. So I'm just going to kind of hit the highlights on those. But if you need to go back and look at them, they are on page 380 in your book. But these kind of just gives us some helpful hints on how to start on one of these trig identities. So first of all, they say to work with one side of the equation at a time, and it's usually helpful if you start with the side that's more complicated looking. The second guideline is to look for opportunities to factor, add fractions, create a common denominator, that kind of thing. The third hint is to remember your identities. Okay, so this is where it comes into play. If you know those well, then that'll make these a little easier for you, but know those identities. Remember that sine and cosine go well together. So do secant and tangent, cosecant and cotangent, because of those Pythagorean identities. If the fourth guideline says that if you're not having any luck and you don't really know where to start, one thing you could do is change everything to sine and cosine. Since those work so well together, sometimes that kind of leads you in the right direction. But then the most important guideline is number 5. Try something. Don't quit and just give up because you're so frustrated. Sometimes even dead ends will provide some insights on what direction to head in. Okay, so to start this, we're going to look at this first example. It says to verify, and our identity is secant squared theta minus 1 over secant squared theta, and that's equal to sine squared theta. So if we're following our guidelines, the first thing we would do is pick out which side looks more complicated. So not too bad on this one. The left side looks more complicated, doesn't it? Okay, so to start with, I'm going to split this fraction up on the left. So that just means I can write it as secant squared theta over secant squared theta minus 1 over secant squared theta. Okay, well, secant squared over secant squared is equal to 1. And 1 over secant, we know that that is cosine. And so since it's squared, I'll just make it cosine squared. And then now this should look like an identity. 1 minus cosine squared is sine squared. And sure enough, that is what the right side was. So I'm just going to bring that down. Okay. So you're trying to get the left side and the right side to be the same. Okay? So still pretty much like what we were doing, but like I said, knowing what direction to go in, sometimes that's helpful. Now, is this the only way you could work the problem? Not necessarily. In your book, they kind of went through it a different way. If you want to see that on page 381. Okay, this one was example 1. So basically what they did was, instead of splitting up the fraction, they recognized that that numerator, the secant squared theta minus 1, looked like a Pythagorean identity, and they went that route. Okay, so if you want to see another way to go about it, there it is. Now, since there's multiple ways you could do these problems, how do you know if you're right? Well, once again, one side's supposed to equal the other, okay? And as long as you didn't make up your own algebra rules or identities along the way, then you're on the right path. Okay, next example. This time we're going to verify 2 secant squared alpha is equal to 1 over 1 minus sine alpha plus 1 over 1 plus sine alpha. So I don't know if you've seen that Greek letter before, but that little fish looking symbol, that's the alpha symbol. Okay, so we've been using theta a lot, but you can use any Greek letters. It's just theta is probably the most popular. But actually the alpha is kind of fun to draw, so you may find that that's your favorite. Okay, so verifying here, on the right-hand side, I think that's the more complicated side this time. So that's what I would focus on. So on the previous example, we looked at the left side, but this time it's looking like the right side. Now, when we were simplifying identities, we always said when you add fractions, what do you need to do? Okay, so that's the step we're going to start with here. We're going to get a common denominator of 1 minus sine alpha times 1 plus sine alpha. So when I look at that numerator, or that first fraction, sorry, what's missing in the denominator? See how I'm missing a 1 plus sine alpha? So that's what I need to multiply by over here. So 1 times 1 plus sine alpha is just 1 plus sine alpha. Okay, then for my second fraction, see how I'm missing the 1 minus sine? So that's what I multiply the top by. So that becomes 1 minus sine alpha. So now when you look in your numerator, what happens? See how your signs will cancel out? Okay, so that just leaves me with 1 plus 1, which is 2. Okay. And then I can even take the bottom, 1 minus sine and 1 plus sine, and multiply that out. That's going to give me 1 minus sine squared alpha. And what does 1 minus sine squared equal? Okay, that's your form of that sine squared plus cosine squared equals 1 Pythagorean identity. So that's equal to cosine squared. And if I'm dividing by cosine squared, that's the same thing as multiplying by secant squared, because secant and cosine are reciprocal. So I just use the reciprocal identity there. Okay, and sure enough, wasn't that my left-hand side? Okay, so we've got that one. Okay, moving on to the next example. This time we're going to verify tangent squared x plus 1 times cosine squared x minus 1, and that's going to equal negative tangent squared x. So which side is more complicated? Going back to the left this time, aren't we? Okay. Now, a lot of times when you see the two parentheses like that, what we have on the left, you may think to FOIL, and sometimes foiling will work. We used FOIL back here on this last example in that denominator, okay? But this time, since I have the squared and the plus 1 and the minus 1, I'm thinking that we're probably going to use a Pythagorean identity instead. Does tangent squared x plus 1 equal anything? Okay, that's equal to secant squared x from our Pythagorean identity. It's really weird asking you all questions and then I have to answer them myself. I'm trying to pause so you can think for a second, but this is a struggle. Okay, cosine squared x minus 1. Okay, that looks somewhat similar to a Pythagorean identity, but it's flipped. Okay, we know sine squared is 1 minus cosine squared. Okay, so do you remember we had a problem in one of the previous notes where that happened? Do you remember what we did to make it work when the signs were backwards? Yeah, that just made our sine squared x negative. Okay. Now, see how this is, to me, a little easier than the simplifying, because now I'm seeing, okay, I've got a negative in there. That's good, because look at the right side. See how you have a negative in there? So I'm thinking we're on the right track. Okay. Now, I can also see that I have tangent on the right, and I know tangent is sine over cosine. So I've got my sine in there now, but I don't have my cosine. Okay, but I'm kind of working towards that. Okay, secant squared is the same thing as 1 over cosine squared. That's one of our reciprocal identities. So if I write that secant squared is 1 over cosine squared, then I can multiply here and I end up with negative sine squared x over cosine squared x. And what does that equal? Yep, tangent squared x. Actually, negative tangent squared x, which is what we wanted, because the right side has negative and I forgot to bring that negative with my tangent. Okay, one more example, and then we'll stop for the day. I know this is a lot to take in, but pretty much the next 3 or 4 days is just going to be more practice on this verifying stuff. So we're going to make sure you get the hang of it. All right, on this example, we have to verify tangent x plus cotangent x equals secant x times cosecant x. Now, this is one where, okay, it's not as obvious as far as which side is more complicated. Okay, so I'm thinking I'll probably just go with the left, but you probably could go either route. I'm thinking the left just because of the adding. Okay. Now, when I do see the right side, secant and cosecant, I can remember that secant and cosecant are the reciprocals of what? So here I am answering my own question again. But once you remember that secant and cosecant are reciprocals of sine and cosine, that gives you some insight on what to do on the left side. Let's rewrite everything in terms of sine and cosine because we might be able to get it to match up with the right side a little faster. So we know that tangent is sine over cosine. And what's cotangent? Okay, now we're adding fractions. So what have we said all along we need to do when we add fractions? So our common denominator will be cosine x sine x. So what do I multiply the first fraction by to get my new denominator? So that's going to give me sine squared x. What do I multiply the second fraction by to get my new denominator? So that gives me cosine squared x. Okay. Now, when I look at this part in the top, what does that equal? Do you recognize it? Okay, so that Pythagorean theorem makes the numerator, or the Pythagorean identity makes the numerator 1, and then over cosine x sine x, and 1 over cosine is secant, and what's 1 over sine? Whoops. So while I know these are challenging, once you kind of start to get the hang of it, you're going to, I think you're going to like them. They're kind of like little puzzles that you're trying to figure out. And you feel really, really smart when you finally get one that you've been working on for a while. So there's something about that sense of accomplishment that makes you feel good. You'll also find the more of these you do, you're going to find like a lot of the same things happening over and over. And I think they'll start to get easier for you. So just wanted to give you a little encouraging pep talk. Hang in there. Like I said, send me questions your way. I can work some stuff out and then send it to all of you so that you'll have it. And then also be sure and try to reach out to someone else in your class. and make sure that you try to help each other. Okay, your assignment is going to be in the book this time, page 385. We're going to work on 3 through 20 all. And these are going to be a little tougher to check in the back because if I remember correctly, they just say various answers or something like that. But you know what the answer should be. The left side should look like the right side at the end, okay? But once again, just send some messages my way if you need help with a specific problem or so. And then we'll be working on this throughout the rest of the week. We're going to do a math lab tomorrow, and then we'll do a little worksheet review over both 5.1 and 5.2. And then it looks like we have a catch-up day before we get ready to review and take a quiz over this stuff. So, hope you all are doing well. I miss you all. It's not quite the same having to answer my own questions as I'm teaching, but I'm trying to make the best of it. I'm outside making notes so that I can at least enjoy the fresh air and scenery. So, hope you're doing well. Talk to you.